Recently I was using KiCAD. It's an open source software for electrical schematic design and for PCB layout. When you have a component being laid out on the PCB in FreeCAD, you need a footprint. The problem is that KiCAD doesn't really have very good tools for creating footprints of components that are not available in its library. So you need another way to create footprints effectively and quickly. And to do this, I had to end up using FreeCAD. FreeCAD is a software that is a mechanical design software that's very good. It has very good tools for basically creation of dimensioned parts. So what I want to do today is to show you how I created a footprint in KiCAD and a PCB outline using FreeCAD, and how I used the footprint and the component 3D model to generate a 3D model of the PCB and export it back into FreeCAD for integration with other mechanical components. So here's FreeCAD open. Now, before I get to using FreeCAD, first thing I need to do is look up the component in DigiKey and find the datasheet, and if there's a 3D model available, grab the 3D model of that component as well. So if you look on the screen, I have here the DigiKey component that I'm going to be using. It's this component here. This is just an arbitrary NMOS dual package IC. When you get to here, what you first need to do is download the datasheet. So I'm going to go ahead and do that. Click the download button and save this. I have a folder created for this project with a few different categories. So I'm just going to save it into the datasheets category, so like so. So here we have the datasheet. Now, in this datasheet, we see a few different things. We see the top view of the actual component. More useful is at the end of the datasheet, we have two sets of dimensions. One is the dimensions of the actual component. This is going to be extremely useful for if you're designing a component. In our case, we're not actually designing the 3D model of the component itself. We just really want the footprint of the component. The first task is to take this, we're going to expand this out. Let's take a screenshot, and we're going to grab, and we're just going to save this into our folder, and we're going to store it into the datasheets folder. So in FreeCAD, we basically need to create a footprint based on the template shown inside the datasheet. So the first thing we're going to do is start off by creating a new document, and we're just going to save it under the folder called FreeCAD. So we'll save that. So I'm going to create the part, and let's call this rename footprint. We need to actually take our screenshot and import it into FreeCAD so that we can use it as a template. So let's go ahead and do that. We're going to use the image workbench. And in here we can actually see, using this view tool, we can actually see what our screenshot looks like. Let's go to datasheets and footprint.png. Here's our screenshot. And let's do open an image plane. And we're going to stick this on the XY plane and click OK. So there is our footprint. So we can rotate it and have a look at it. So what we want to do next is to maybe change the appearance of this image plane and make it a little bit more transparent so it's easier to see our sketch on top of it, like so. There we go. And now we're going to go into Sketcher. And in Sketcher, we're basically going to sketch our real footprint. So to do that, from Sketcher, we can create a new sketch. And we can put the sketch on the XY plane. And now in the sketch, we can draw out one of the paths. We zoom into here. We can give it an actual dimension here. So if you look here, the X dimension is 0.42. So let's go ahead and label that 0.42. And the Y dimension is 0.6. So let's label that 0.6. And now we have our real pad size. And you see there's a problem. Our real pad size is way off from the actual template size. So what we need to do is scale the template down to the correct size. What we'll do is we'll place this part in the correct location, and then we'll create a reference line. And the goal of this reference line is to basically help us understand what the current scale of our template really is. So from here, we'll just remember these numbers, 14.15 and 0.42. And we're going to go back into our image, And we're going to modify the X and Y size, 14.15. So multiply by 4.2 divided by 14.15. So that should scale our dimension, but we want to scale it evenly. So we're going to scale both the X and Y. Oh, look, we made a mistake. So actually we made a mistake with the scaling. That's okay. So we're just going to double check that, see what happened. 4.22 to 0.42. Oh, I see the mistake. Should be 0.42 times 0.42 divided by 4.22. And let's copy that and stick it into here as well. Times, there we go. So now this should fix the problem. So we see, okay, there we go. There we have a perfect fit. You notice that if you look at the template's center 0, 0 is not the same as the sketch center. So let's align those two together. And we'll just make the origin visible so we know where the sketch origin is likely to be. And we're going to double click on the image plane. 1 micrometer increment is good so that we can step precisely. And now we're going to move our sketch, our template I should say, so that the center of the template is the center of our origin. So here we go, that's aligned. So now we can enter our sketch again and we can align our sketch to the right location. And what we're going to do here is we can actually pattern 6 of these since they're all the same size, and that should be a good way to actually get the sketch completed quickly. So we're just going to grab that, and we're going to create a rectangular array. So let's do that. Repeat this process, and voila. What we need to do is just dimension these properly. So let's go ahead and try to do that. I'm just going to clean up some of the dimensioning. We need the C value here. So C value is 0.650. The separation between these two should be 0.650, which should be, there it is. Okay. So this should be 0.650. So 0.650, and there we go. So now if we align these should all be aligned with the template. So now we have to do the same thing with our other dimension here. And what is that dimension here? So y is actually y1 minus y. y1 is 2.5, y is 0.6. So 2.5 minus 0.6 should be our dimension there. And now if everything was done correctly, these should all be aligned now. We can hide these dimensions just clicking here and remove them from the picture. And this sketch is still not fully constrained yet, so what we want to do is just center it around this point here. So we'll just grab 2 of the points, put a centering constraint, and now it's centered and along one axis but not the other, so let's do the other axis as well. These 2 points used with this center. So there we go. And now the sketch is turned completely green, we're done. If you were to take this image and export it as, say, a DXF into KiCAD, we'd have loads and loads of problems. The reason is that when you export a footprint, KiCAD doesn't know what a pad looks like or where the pad is located. So in order to get KiCAD to recognize that this image that we're seeing on the screen, this image is an actual set of pads, of 6 pads, we have to put in additional markers into each of the individual pads to identify them. And then we have to convert these different pads into polygons. So if you were to do this without converting them into polygons, when we import into KiCAD, then KiCAD would not know where the closed area of the pad really should be. I'm going to go into our KiCAD Step-Up Workbench. This is a workbench that you can find if you look under Tools and Add-on Manager. Here, in this workbench, we have a tool called Polyline Sketch. Before we do that, what we're going to do is, when this tool is run, it identifies little circles inside the pad polygons. It's very important that these circles are added at the right time. So you have to make sure that all your pads and all your footprint geometry is completed before you add the circles. If for some reason you added the circles in between, there's some bug in KiCAD Step Up that actually does not correctly recognize the pads. And so you won't be able to export them into KiCAD, and in fact it'll cause a lot of frustration because you won't be able to figure out why. Here we'll go back into the sketch, and what we're going to do is add some circles inside each of the pads, like so. The dimensions of the circles aren't important. So oops, let's do that one again. There we go. And so we've got these 6 circles. So now we'll take the sketch and basically go in and convert it into a polygon. And so here we go. This is the instructions. Add circles inside each closed polygon in order to recognize it as a pad. We've already done that. So we've got a new sketch created, which is called pads poly. And this pads poly, we're going to take this and from it generate a footprint. So we have a footprint. Oops. So we have a footprint generator here. So let's click on that. Go to KiCAD, and we're going to add a footprint file here. And it's useful now to look at the report view and just verify that all the polygons, all the pads in your footprint have been detected correctly. So there's 6 pads. So we should see 6 closed paths here, which we do. And we should see 6 different polygons found, which we do as well, and the coordinates. So this is the coordinates of the circles, I believe. Let's open up KiCAD. So here we are. And we're just going to create a new project, and we'll put the project here under KiCAD, and let's call it MOSFET driver. So the first thing we need to do is we need to create a schematic. And in the schematic, we need to add some components. So specifically, what I'll do today is add 2 dual PMOS transistors, and I'll just wire them up at random just so that I can give you an example. But before I do that, I need to create a symbol for this dual MOSFET. So the first thing I'll do is create edit symbol. And there's some libraries that I'm not using here, so for now it's okay. I'll ignore that error. And what we're going to do is create a new library. Let's call this library the MOSFET driver library. So save that. And we just want to use this for our project. We don't want it available globally for all our other projects. So we'll just click that. And now if we do a search, we should find our MOSFET driver library right here. And inside here, we're going to create a new symbol. So let's do that. New symbol, both an NMOS and a PMOS in this package. To make our life simpler, we're just going to borrow an NMOS and a PMOS from another symbol and use that. Here we are. So we're just going to copy these, Control C. This is an NMOS, so let's copy the NMOS in here, and Control V. And now let's grab our PMOS. Here's a PMOS. Let's Control C that, and now put that also into our symbol. And there we go. So now we need to correctly identify these pins. So we need to go back to our datasheet and verify how the pins should be numbered. So here's the pin numbering: 1, 2, 3, 4, 5, 6. So let's see, source 1 is 1, gate 1 is 2, and D1, drain 1 is 6. So let's label those. This should be 1 is source 1. This should be 2 is gate 1. And this should be 6, which is gate drain 1. Like so. So now we can go ahead and do the same thing for our PMOS. Let's have a look at our PMOS. Our PMOS is pins 4, 5, and 3. 5 and 3. And now what we need to do is create a footprint for this. So at this stage, we're going to close this off, and we'll come back to our schematic and go to the footprint editor. So we'll ignore that error. That error is just because I had a library loaded that's not available any longer. So now we need to create a new library for the footprints. We'll call this MOSFET driver.pretty, and just for the project. Now we're going to create a new footprint, but this time we'll import the footprint rather than creating it from scratch. Import footprint from KiCAD, and we have here the footprint right over here. So let's click on that, and here we see immediately the footprint is imported. So we need to now update the pad number. So we're just going to put in a little circle here, just on the silk screen layer, as a reference for pin number 1. Now that we have it, we'll relabel these pads. So let's save that under our MOSFET library. Let's look for it, MOSFET driver. Here we are. And voila, we've saved our footprint. So let's, one thing we can do is we can relabel that. Let's give this a new name, save as, and let's call it SOT 363, which is the type of package that we'll be using. Yes, and there we go. So now we're ready to link the symbol and the package, the symbol and the footprint. And let's go back to our component library, symbol library. Let's go to our MOSFET driver, double click, and assign a footprint. So let's go to our MOSFET. There we are. And let's add that to our footprint. And we can also insert our datasheet. So we had a datasheet from DigiKey. We can link the datasheet as well, like so. And there we go. So now at this stage, so what we need to make sure is that source 1, gate 1, spin 2, drain 3 should not be there, should be drain 2. So at this stage, we can go back to our schematic and we can add a new component. There we are. Let's add 2 of them, just so that I can give you a good example of how this all comes together. So for now, I'm just going to connect these up randomly with wires. These are by no means correct or accurate. Let's switch to our PCB view. We can go in and use this tool here. And everything looks okay. You can annotate and update the PCB and close. And now what we need to do is actually make a board outline. So if we want to do a custom board outline, we can do that, or we can use KiCAD's inbuilt tools. To use KiCAD's inbuilt tools, we basically have to draw 4 lines around here. But what I want to show you today is how you can do this with FreeCAD. So with FreeCAD, you can make more complicated board outlines, and they can be useful in and of themselves. Now let's actually create a new part. We're going to create a sketch on the XY plane. We need to make sure it's bigger than the 2 ICs together. We need something about 5 millimeters or wider and 3 millimeters or longer. So let's create a hexagonal outline. So we'll just use the line tool and we'll draw ourselves something that looks like that. And let's make everything a little bit more symmetric. And there we go. So now let's give this a dimension. And so now we have a completed board outline. Let's close this. We will export it as a DXF. And let's choose Autodesk DXF and call it outline. And now when we go back in here, we can now go ahead and import the same file. And voila, we've got a hexagonal board outline that's a little bit bigger. So Now let's bring the silk screen in so that it's visible on the board, like so. And we're done. So let's save this. And now what we can do is we can generate a 3D model. So KiCAD has a very convenient viewer for 3D modeling. So here's a 3D viewer. So one thing missing from our current 3D model is the actual SOT 363 package. So at this stage, what we need to do is go into our footprint and add a 3D model to our footprint. So what we'll do is go back to our footprint editor, open it up, we'll go to our MOSFET library, here it is, and now we're going to go in and do some footprint property management. See, there's 3 settings here. We'll go to the 3D settings. This is our 3D board. And what we're going to do is get rid of this random file. We don't need that. We're going to replace it with the path name for our actual 3D model. So in here, we need to add a 3D model. So we'll go to the DigiKey website, and here there's a 3D model by Ultra Librarian, and we're just going to download this 3D model here. So 3D model, step file, download, and let's go back to our footprint library. So in here, we need to replace this with the name of this model here. So let's unzip this. Here's the model, extract it. Okay. And we can get rid of the zip file. This is the model. There we go. There's our 3D model. What you'll see is that it's actually not correctly positioned. So there's our pin number 1 marker over there. So we need to rotate this in this direction by 90 degrees. That's, I think that'll be, there we go. And voila. Now that that's saved, actually, we need to go back into our schematic here and just do an update of this. Apply. Okay. And so now what we should see in the 3D settings, there we are. There's our 3D model. So now we're ready to take this and export it as a 3D model. The way we're going to do that is not to use the KiCAD tools in the FreeCAD KiCAD Step Up workbench. Rather, we're going to go ahead and export this as a VRML. The VRML allows you to preserve things like the tracks and the traces and the pads and the labels on the board as well, which doesn't happen when you do an import from FreeCAD using the workbench. So let's do that right now. So let's convert to VRML. And there we go, saved. And now let's actually open and import our VRML file. So we can go into Step. Here it is. And there we go. We have our board. So now we can use this board in whatever project we want, and hopefully build something bigger and better.